Good morning. Today topic name is various forms of pull-up for nmos inverter. My name is N Balaji from EC department. Subject is VLSI design. So coming into the introduction, MOSFET digital circuits. The late 70s, as the era of LSI and VLSI design began, NMOS became the fabrication technology of choice. Later, the design flexibility and other advantages of the CMOS were realized. CMOS technology then replaced NMOS at all level of integration. The small transistor size and low power dissipation of CMOS circuits demonstration principal advantage of CMOS over NMOS circuits. NMOS inverter for any IC technology used in digital circuit design, the basic circuit element is a logic inverter. Once the operation and characterization of a inverter circuit are truly understood, the result can be extended to the design of logic gates and more complex circuits. N-channel MOSFET. So this is a diagram of the N-channel MOSFET. N-channel MOSFET has two modes, enhancement mode and depletion mode. This is a terminal diagram of the MOSFET. NMOS inverter. If Vi is less than Vtn, the transistor is in cutoff and ID equal to 0. There is no voltage drop across RD and the output voltage is V0 equal to VDD equal to VDS. If Vi is greater than Vtn, the transistor is on and initially is biased in saturation region since VDS is less than VGS minus Vtn. As the input voltage increases, the drain to the source voltage decreases and the transistor enter into the non-saturation region. NMOS inverter with resistor load. So this is a VI characteristics of the NMOS inverter with resistor load. The resistor load is applied to the VDD of resistance of RD at the output of the NMOS inverter, where the V0 equal to VDD equal to VDS. So the cutoff, if the Vi is less than Vtn, the transistor is in cutoff and at equal to 0 as said before. There is no voltage drop across RD and the output voltage is V0 equal to VD equal to VDS. NMOS inverter with resistor load in saturation region. As the input is increased slightly above the Vtn, the transistor turns on is in the saturation region where V0 equal to VDD minus ID into RD, where equal to Kn equal to Vi minus Vtn whole square. NMOS inverter with resistor load in transition region. As input voltage is further increases and voltage drop across the RD becomes sufficient to reduce the VDS such that VDS is less than or equal to VGS minus Vtn. The Q point of the transistor moves up the load line where the V0 equal to Vi minus Vtn, where the Kn Rd of Vit minus Vtn whole square plus Vit minus Vtn whole square into Vd equal to 0. NMOS inverter with resistor load in non-saturation region. As the input voltage becomes greater than Vh, the Q point continues to move up the load line and the transistor becomes biased in the non-saturation region where V0 equal to VDD minus Kn Rd of 2 of Vn minus Vtn into V0 minus V0 square. NMOS inverter with resistor load input-output relation. The sharpness of the transition region increases with increases of load resistance. The minimum voltage output voltage or the logic 0 level for a high input decreases with the increasing load resistance. N-channel MOSFET connected as saturated load device and N-channel enhancement mode MOSFET with an connected to the drain can be used as a load device in an NMOS inverter. Since the gate and the drain of the transistor are connected, we have VGS equal to VDS When VGS equal to VDS is greater than VT, a non-zero drain current is induced in the transistor, and thus the transistor operates saturation only. And following conduction is satisfied where VDS is greater than VGS minus VTN. Finally, ID equal to Kn into VGS minus VTN whole square equal to Kn into VDN minus VDN whole square. In the saturation region, the current is nmos inverter with enhancement load. The basic inverter consists of the two enhancement only nmos transistor, much more practical than the resistor load inverter because the resistors are thousands of times larger size in the MOSFET. Where an n-channel enhancement mode MOSFET with gate connected to the drain can be used as a load device. N-channel MOSFET connected as a saturation load device where the ID equal to Kn of VGS minus VDN whole square. The transistor with the connection always operates in the saturation region when not in cutoff. NMOS inverter in the enhancement load when when V1 is greater than less than VTN, the driver is cut off and drain current is 0. For the enhancement load NMOS inverter, the maximum output voltage, which is logic 1 level, does not reach the full VPP value, where the driver transistor turns on and is biased in the saturation region. Two drain currents are equal since the output will be connected to the gate of other MOS transistor. As the input voltage increases, the driver Q point moves up the load curve and the output voltage decreases linearly with the V1. NMOS inverter with enhancement load. And the NMOS V0 is equal to driver, the transistor Q point continues to move up the load curve and the driver comes biased in the non-saturation region. NMOS inverter with the depletion load. Depletion mode is a channel exists with zero gate value. The negative voltage must be applied to the gate to turn device off. Threshold voltage is always negative. This is alternative form of NMOS inverter that uses an depletion mode MOSFET load use device with gate and source terminal connected. This inverter has the advantage of V0 equal to VDD as well as more transition region even though V by L ratio for the output MOSFET is small. N-channel depletion MOSFET, N-channel depletion mode MOSFET. In a channel depletion mode MOSFET, an N-channel region or inversion layer exists under the gate oxide layer even at zero gate voltage and hence term depletion mode. A negative voltage must be applied to the gate to turn the device off. The threshold voltage is always negative for the kind of devices. NMOS inverter with depletion load gate and sources are connected. VGS is equal to 0 since the threshold voltage of the load transistor is negative. VDL SAT equal to VGSL minus VTL minus VTN equal to 0. NMOS inverter with a depletion load. The driver transistor characteristics of the load curve, where the VDS of VSAT is equal to VGS minus VTN. Thank you.